Hi everyone, how's it going today? I'll go ahead and get started in just one more minute. On my screen, you'll notice a couple different links at the bottom for our GitHub repo and also the YouTube. So for the GitHub repo, it has the material that I'm going to be using today, mainly as a reference. We're going to spend most of the time today in Azure Machine Learning. So I'll have this open and come back to it, but this is a great resource if you'd like to follow along on your own, either now or later. And I'll go ahead and show my browser specifically. So if you follow that link at aka.ms/reactors_online, that will take you here. And what I'm going to be going through is the regression directory. So this first notebook here has the Python notebook that I used at the session a couple weeks ago. And no worries if you weren't able to catch that. I will do my best to provide enough context today about what was covered in that session, but just so you know, you can always come back here and reference that and go through the notebook at your own pace. The notebook that I'm going to be using is the second one here, the Regression Azure Machine Learning notebook. And I'm also going to be using the same data set, which I'll talk about as we get started. But that's the basic resources that I'm going to be using today. Additionally, if you want to follow along, you will also need an Azure account because we are going to be using Azure Machine Learning. So we're going to need to set up a workspace there to get started. So you're going to need a couple different things, but mainly you'll need your Azure account to get started. And I can go ahead and paste that link in here in case anyone needs one. Before I jump into the content, I'll just start with an introduction about myself. My name is Meaghan Lewis. I'm a senior program manager at Microsoft. I focus on our Microsoft Reactors business, and I really think about emerging technologies. That's kind of my content area. So I'm constantly developing and delivering content around that area. I also, me and my team are here today. My coworker Sarah is online, Dr. Guthel, so please feel free to engage with us as much as you'd like in the chat and answer and ask questions, or you can answer questions too. And there's going to be lots of time today as I'm running different experiments in Azure Machine Learning to go ahead and pause and take some time to answer questions. So just a little bit more about the reactors. I don't need to say much because I'm assuming some of y'all already know, but just I wanted to say that we're continuing to kind of iterate on our online streaming process, and we just love to hear from you, whether it's about what you thought about the content today or any other streams, any content on the GitHub repo, and just we'd like to know what else that you'd like to see. So please feel free to reach out. I can also drop my contact info in the chat, and I'll definitely show it at the end of the session as well. Cool. Where's everyone tuning in from today? I'm curious. I'm at my house in Oakland, California, and it's really hot today. So if I'm sweating, that's why. So please excuse that. But yeah, I guess we can go ahead and get started. So like I mentioned, I'm going to be mainly covering what's in this Azure notebook today. And we are going to be using Azure Machine Learning. So Azure Machine Learning is a cloud-based tool that you can use to train, deploy, and manage machine learning models. So this service is really great because it works with any kind of machine learning that you're doing. It doesn't matter if it's unsupervised, supervised, or what kind of model you're building out. Additionally, it's pretty friendly and easy to get started with, whether you're a developer, data science, or just getting started. I think it's friendly for all levels of experience. And as you can see today, I'm not really going to be writing any code. It is going to be very hands-on. But what I'm going to be using in Azure Machine Learning is this designer feature, which allows me to drag and drop and kind of create this machine learning model and run it and see the results there. So let me quickly switch over to my browser. I'm going to be doing a little bit of switching back and forth. But in my browser, you should be able to see it momentarily. So in my browser, I'm just showing a little bit of detail about Azure Machine Learning. And I'll go ahead and drop that link in here too. But this is a great place to come if you want to learn a little bit more about the product, how to get started, see all the documentation here that exists for Azure Machine Learning. This is also just something that I want to take a moment to highlight, just the different development tools, languages, and frameworks that Azure Machine Learning supports. So again, it's very flexible and open platform that kind of allows you to do what you want with the skills that you have. So without further ado, let me go ahead and just jump right into getting started with Azure Machine Learning, because there is a lot that I want to cover in the next 50 or so minutes. So here I am in Azure. So this is at portal.azure.com. And again, to come here, you're going to need to have your own Azure account. And so what I'm going to start by doing is to create an Azure Machine Learning workspace. And I'm going to just go ahead and give my workspace some name and select the subscription that I want to use. And then I'm going to create a new resource group. And specify a location for this. I'm going to go ahead and choose Central US. And then I need to choose a workspace edition. So for now, I'm just going to select Enterprise, and I'll tell you why in a minute and what the difference are between Basic and Enterprise. But let me go ahead and create that, because it's going to take just one moment. So I can review. I see that my workspace is in progress now. And so over on this tab here, you can find a little bit more information about the different Azure Machine Learning editions and what there is to offer between the basic and the enterprise versions. So you'll notice that not everything is included in the basic version. And primarily what we're going to spend a lot of time doing today is using the Azure Machine Learning Designer. So I do need that enterprise edition to go ahead and do that. But let me go ahead and drop that here so you can see a little bit more detail about the pricing and the differences between those two versions. So back over on my Azure portal, I see that my deployment is underway. And it should just take another moment, and then we'll be able to jump into these exercises. Also, a fair heads up, there is going to be some downtime as I am running experiments and doing different deployments with Azure. So this is a great time to ask questions, because I'm definitely monitoring the chat when I'm just kind of waiting for deployments and things to happen. Sweet. Okay. So now that my resource is here, let me go to that resource. And once I do that, I see this big banner here to try the new Azure Machine Learning Studio. So I'll launch that. And then once this is launched, I'll do a quick little tour here. All right, so this is the default Azure Machine Learning Studio view. And there are a few different things that I want to highlight initially. So there are these authoring tools over on the left-hand side, and we're going to be using the designer like I mentioned today. And that is a really cool way to easily create machine learning models and other models too. We're going to start by uploading a data set. And we're also going to be creating different experiments and pipelines. So these are all of our assets here. And then we're also going to need different management resources. So a couple different things that I'll need are compute instances. So let me go ahead and create these so we don't have to spend time waiting for them now. But there are different types of compute instances that you need here. And there is some explanation here at the top about kind of what this compute is doing if you're unsure, but there are two different things that I need. So first is just going to be this compute cluster that is going to allow me to actually train, test, and deploy my model, or train and test. There's a different one for deploy. So let me go ahead and call this, it's going to be in the default region of my workspace. I'm going to use the CPU processing unit and stick with that default virtual machine size. All right, so let me go ahead and create that. And then I'm also going to need an inference cluster. So this is going to be a cluster that I'm going to use later, probably one of the last things that we're going to do today. It's going to allow me to deploy my model on an Azure Managed Kubernetes cluster. So I'm going to create that just in case it takes a long time to create later. I don't want to have to wait. All right, you should also be in the same region as my workspace, another cluster. This is going to load a virtual machine size for me. All right, has a default number of nodes. Let me just go ahead and create that. And then we're good to go. Also, I apologize if you hear a slight banging behind me. There is some construction going on next door, unfortunately. All right, so now I'm going to go ahead and import my data set. And then we can take a moment to talk about that. So I'm going to import this data set from a local file. And that is called un11.csv. This is tabular data. I am going to use this previously created data store. Let me go ahead and browse for my data set. All right, there we go. So that's this un11.csv file. And again, this CSV file is in the GitHub repo. And at the next step, I'll get a little bit of a preview of my data. And this is allowing me to get a quick peek into what's in the CSV file. And you'll notice that I have these default column names. So let me go ahead and get rid of those. I want to use the headers from the first file. And then I notice that that updates here. So I no longer have those default column names. I have the column names that I want to use. Here you'll get a glimpse into the data. I have this region column, which has different regions of where these people are coming from. There is a group here. There are 3 groups: Other, Africa, and OECD. So I'll start with Africa because that's probably the most obvious one. These are people who are living on the African continent. There is OECD. I forget exactly what that stands for. Something about economic something, but this is basically a collection of probably about 30 or so European countries. I would say mainly European countries. And you'll see those labeled with OECD. Everything outside of OECD or Africa is just other. Here is the fertility rate, as well as my per capita GDP. So this is basically just a representation of the economic status for that group. And I have the life expectancy of a female, which is what I'm going to be actually predicting or modeling today as my target. And then the percent urban. So basically this is describing how urban of a population that person lives in. All right. So this is just a schema. Let me just finish importing this data. We're good to go there. Cool. So now we're creating that data set, and I see that here under my data sets tab and under assets. And now what I want to do is to go over to the designer. And I'm going to go ahead and start generating my model here. So just to do a very quick peek, I cannot say that word today. So just to do a very quick peek, I want to show you what a complete model looks like. So what's really nice about Azure Machine Learning is I find that there is lots of documentation and examples to help you get started, even if you are unsure. So this is a pre-built model that we can reference, and you can kind of see the default steps of this model, starting with importing the data, selecting columns in the data set, doing things like cleaning and splitting data, and then all the way up to evaluating the model. So this is great because, again, it just kind of gives you an understanding of generally what's going on here, and you can feel free to run an experiment with this model on your own to see the results and then to give you an idea of how to use this on your own. Let me now go back to the designer, and I'm going to go ahead and create a new module. And this is going to be referred to as a pipeline. I'm going to start by changing that name. Cool, so this is going to be my simple linear regression model. And you'll notice here over on the right in the settings panel that it's complaining that I need to select a compute target to run the pipeline. So that's why I went ahead and created that compute target earlier. So I should just now select the default so I don't have to worry about doing this again for this particular pipeline. I know that it's always going to run on that compute. And now I don't have to look at that anymore. So what I'm going to start by doing over here on this left-hand panel, and this is basically how I'm going to build out my entire model. I'm going to import this un11.csv module. And then the next thing that I want to do is select the columns that I want to use in my model. So I'm going to go to the data transformation, and I can go ahead and drag this over here and connect these two. And then from there, I have settings for this particular module. So here I can go ahead and select the columns that I want to use. And for this example, we're going to be doing simple linear regression. So what I'm going to be looking at is using one independent variable as my predictor, which is going to be that per capita GDP. And I'm going to be predicting the life expectancy of a female. So that's my target. So those are the two columns that I want to focus on initially. And then after that, what I want to do is train my model. And a nice thing here is I don't know exactly where all the modules are, so it's really nice to be able to just type what I'm looking for over here and show that. So I'm going to just drop that into there. And then I'll need to connect this. So I'm going to connect So I'm going to connect one receptor over to this trained model. And then I, at the same time, am going to look for this linear regression and plop this over here. And I'm going to go with the defaults for now. I'm not going to change this. We will be changing that later. I am going to select or enter a random seed number of 42. And essentially what this is doing is just describing the order that my data is going to be randomly modeled. And so let me go ahead and connect this now to my trained model. And what's nice about this is, if you noticed, let me get rid of that quickly. Sometimes if you're not sure about exactly how to connect this, I mean, there's only one option really here, but it will do a little highlight for you to indicate that that is actually the correct receptor that you want to select. So then after I train my model, and I need to go ahead and specify which column that I'm looking for as my target. So again, this is going to be the life expectancy of a female. And then after that, what I want to do is score my model. So I'm going to plop that under here, and I'm going to connect one receptor to the upper left-hand side of score model. And then I'm going to connect another receptor down here to the right-hand side of my score model. And then finally, the last thing that I need to do is to look for that evaluate model. So that's under the model scoring and evaluation section. And then I can pop this module into there. And I just want to connect that left-hand receptor. And then I should be good to go. So generally speaking, what I'm doing here, you can kind of follow along the flow, but I'm importing this data set, selecting the columns that I want to use, training this model using linear regression, then scoring and evaluating the model. So let's go ahead and run that. And to run this, what I'm going to do is to create a new experiment. So what I'm modeling here is life expectancy. So let's just go ahead and call it that. And now this will just take one moment. All right, so in the meantime, I'm going to go back over to VS Code. And like I mentioned, it's going to take just a minute or so to run this experiment. So if you have any questions, please do ask them. I'm going to take a moment to look at the chat over here and see if I missed anything. Okay, I think we're good. So this is all the steps that I just followed to create that simple linear regression model. And it's quite a few steps, but if you're doing this on your own and you're doing this later, you can definitely kind of just watch the video or go along in the steps. I also added a picture here, which is a nice way to know if you generated your design appropriately, like mine. I do see a comment in here. I think the last time I used this was the classic portal experience. Yes, so I did mean to classify that. This is Azure Machine Learning, and I am using the Studio, but not to be confused by Azure Machine Learning Studio, which is the classic version. So this is kind of the new version that we're using, which is in preview, but I like using this just because it is kind of the newer version of Azure Machine Learning. It's very, very similar. In fact, this designer will look almost exactly the same, but it's just a different experience. And you'll notice that my experiment is still running here. You can see that some of the things are in progress. Some of these other modules are not yet running. So it does sometimes take a moment. This might be a good time to go and get a drink of water, take a quick bathroom break. But let me go back to VS Code in the meantime. And unfortunately, there is a little bit of a spoiler here, but you can see that the R² score, which is the coefficient of determination, which is essentially telling us how good our model is. So when this is done, we're going to be able to see that coefficient of determination by evaluating the model, but surprise, it's going to be 0.30. And so this is kind of the base that we're going to start with by running this simple linear regression. If you're curious about what this data set looks like, you will have to go in the previous notebook that I mentioned. So from here, if you go to aka.ms/reactors_online, in the regression directory, you'll see that there, and that will give you a much better visualization of the data because we don't really get that experience here. I'm kind of just taking the assumption that we already did that local modeling, and now we're taking all this to the cloud to generate these models here and then later share with others. And I do see a question. Hi, sorry, I jumped on 5 minutes late, but what about the train test split before training the model? Yes. That is a very good point, and that is definitely best practices to actually split your training and testing data before you go ahead and train the model. So I'm not doing that just yet, but we will get to it later, so no worries. And I see someone else say that they can't hear me. I hope y'all can hear me. Definitely let me know if there's a problem with the connection. All right, so we're almost done here, and then we're going to evaluate the model. One thing that I can show is you can do different visualizations here. So here I can look at the score model result visualization. So I see the predictor that I entered, my per capita GDP, and this is my target variable, the life expectancy of a female. So the score labels is basically, those are just my prediction results for life expectancy. And you can see that they're not so great right now, but this is just a prediction. And then I can actually go and evaluate my model. So I'm going to right click to visualize the evaluation results. And when I do that, there are a few different things that I see here. So the first 4 values that I see are describing my error. So typically, the smaller the amount of error, the better for my model. It's hard to say without context, but I mean, just by seeing my coefficient of determination, that's pretty low. I'm going to assume that these are not great errors. I'm going to assume that this model is not fit very accurately yet. And my coefficient of determination, just as a refresher, if you're unsure what that is, again, that's also referred to as the R² score. And this just represents how good my model is, how well it's actually doing at predicting this life expectancy of a female. And it's not great. So what I'm going to do now is to slightly modify my data. And again, from what I saw in the data set when I plotted this data, instead of the per capita GDP going in a kind of perfectly straight line, the result that I see the data points plotted in, it's kind of more of a log figure or form. So what I want to do is change this a little bit. I want to manipulate the data set. And I'll show those steps quickly. So I want to manipulate the data set. And to do that, I want to change the way that I am selecting the columns for my data set. So before selecting the columns for my data set, I want to go ahead and apply a math operation. And what that's going to allow me to do is to take the log 10 base values of my per capita GDP. So instead of having more of a log structure, they're going to be more on a straight line. And that's just going to change the values, because right now they're pretty high values, like in the several hundreds, I think between 400 and 700 or something like that. So my values are going to be much smaller, and that's easier to compare my life expectancy with. So let me go back to the browser. And what I'm going to do is to look for this math operation. Let me search for that. Apply math operation. Okay, and then I'm going to pop this in here. I need to first get rid of this connector, and I'm going to move that up. And then what I want to do there is connect. Let me change that. I want to connect this module to the apply math operation. And I'm going to be looking at log base 10, like I mentioned, and specifically taking the log base 10 of my per capita GDP. So now I'm going to have a new column in my data set, which is going to be called log 10 PPGDP. And so what I'll need to do is to edit this, and I'm no longer going to be using that independent variable. I'm going to be using log 10, and I haven't run this experiment yet, so unfortunately I can't do the nice autocomplete. Log 10 PPGDP, which is a little bit error prone, but that should be correct. So there we go. So now I'm going to go ahead and run this experiment. So I can just click submit. I'm going to go ahead and select to run this existing experiment. And this will take just a couple moments again. So one thing that I do want to show, I'm going to go over to the experiment section on my left-hand side. And I do notice that I have currently one experiment, which is the one that I just ran a moment ago for the simple linear regression. And when I go back to the pipelines page, I can see multiple runs here. So this is just a good way to kind of see what's happened. And it's just like a good way to have a nice history. The designer is where I can actually go and open and visualize this model here in my pipeline. And that is still running. So let me check if there are any questions now. All right, I don't think there are any questions. Please feel free to ask questions. In the meantime, let's go back to VS Code. All right, so these are the steps that I just followed to manipulate my data set. And we'll see the results of those in a minute. There's a little bit of a spoiler alert. Again, we see what happens to our new R-squared score, and that it increases. And we'll get to that in a minute when this is done running. The next example that I'm going to go into once this experiment is complete is multiple regression. So with simple regression, we're just looking at one input and one output. So with multiple regression, we're adding more predictors or more independent variables to our model. So I'm going to start with just adding one more independent variables and then experiment with adding a few more and see what that does to change our R-squared score. Oh, where is my mouse? Sorry, I'll do a better job to try to highlight things. Yeah, I don't know if you can see my mouse here. And let me go back to the browser. And I see that this is still running. So I'm gonna do something a little clever in the meantime so we're not just waiting around. I can clone this pipeline. And this is a good thing to do if I want to just branch off and start making more extreme changes to this pipeline. I do have the history that allows me to actually go back and see what happened in these experiments, but this can actually be a good way to just kind of branch off and create brand new experiments. So let's go ahead and call this multiple regression. And what I can do in here, instead of just selecting that one independent variable, I want to go ahead and add another and see how that changes my R-squared score. So I'm gonna go ahead and add this percentage urban independent variable in. And that's it for multiple regression. I just need to add one more independent variable, and let me go and submit that and run. And I can go ahead and use the same experiment. And now I notice that I have those two different pipelines, like I mentioned. All of my pipelines are currently in the training stage rather, because I am just training them. At the end or towards the end of this session, we'll actually get to deploy these models and see my pipeline type change as I'm testing and deploying the model. So let's go ahead back to this simple linear regression. And it is so close to being done. All right, there we go. So now I right-click to visualize the evaluation results. And I see the same information that I saw before. I believe these error values have gone down slightly, and notice that my coefficient of determination has increased greatly. It went from 30% up to about 60%. So this is just a better, I would say, R-squared score, but can it be better? And we're going to see that after evaluating the results of our multiple regression model, and as we continue to understand how we can continue to fine-tune our model and increase this R-squared score even more. And this one is just finishing up. Should just take a moment. I will call out a couple other things as we are just waiting for this to finish, but I think it's definitely worth just clicking into these different modules and kind of seeing the different outputs that you get. You get a whole series of logs. Sometimes you get nice visualizations here of values that you can see, but this is a good way to kind of dig into all of this a little bit more to understand what's happening. I've also really found this help documentation useful. So if I'm not particularly sure what something is doing or I have more questions about it, I can go ahead and just refer to the help documentation for that module, which is really nice and detailed and provides really good explanations about what that module is doing and what kind of information I should expect to get back from it. So it's still running, almost done there. Almost. I can go and visualize my scored data set. And now I notice that I just have that additional independent variable. I see my predicted scores here, which should be better than they were with just the simple regression model. And then when I evaluate the model here, I see this coefficient of determination, and this is slightly better than my simple linear regression with the log of the PPGDP. I think it went up just by a few points, so it's still at about 60%. But then what happens if I were to go ahead and add more columns in here, and we can see that. So I'm going to add a region, group. I'm basically just going to add everything and see how that actually changes my model. And that should be everything that I want to add. So let me go ahead and save that and kick that off. And because this is going to take a minute, let me go back over to VS Code. And so as a refresher, we just went through the multiple regression example. And I definitely encourage you to just try this out. I think it's best practice as you are evaluating and scoring your models, just to test out what happens when you introduce more complex relationships in the data. So what happens when you add more columns and more predictors to our model? Does that make the model better or worse? And start to understand why. So we can see that this model is going to perform much better. So this went up from 0.60 to 0.81. So that was a 21% increase, which does explain, or which does indicate rather, that there is a lot of information supplied by the other features that can help us to better predict the life expectancy of a female. So by adding all of these other predictors, we are able to then have a better model. But as someone mentioned earlier, I've kind of been following a not so great practice, and that is that I didn't actually split my data. I've just been throwing all of the data from my data set into this linear regression model. And generally speaking, what you need to do before that, and another thing that I didn't show here and didn't really talk through, is that you should make sure that your data is cleaned. And that is definitely an option in Azure Machine Learning to help you clean your data set. But I'm pretty familiar with this data set, and I know that it's clean how I expect it to, so I don't have to worry about doing that. But that is a very important process to machine learning, is making sure you're working with clean data. But I do need to make sure that I am splitting my data between the training data set and the test data set. So I'm going to go through this just in a moment, but I just wanted to give some background about what I'm going to be doing. So I'm going to be splitting my data using 70% of my data for training, and I'm going to specify 42 as the random seed. So this is just indicating I want to use 70% of my data, and I want you to randomly go through and grab this 70%. So I'm not kind of going through the first, there's 199 rows. I don't know how much 70% is of that, like 140. So I'm not just going to be taking the first 140 rows. I'm going to be randomly taking 140 rows. And this is going to allow me to have, I would say, less predictability, or, you know, your data might be ordered in a particular way that could not be conducive to just taking the first something rows. It's better to kind of have a random order, just to ensure that you are following best practices and kind of having R-squared score as a result that is going to be less predictable and is going to better hold up to new data that you're going to introduce to your data set. And we will talk more about that. How can we decrease the computation time? Good question. So one thing that I could have done is I just kind of went with the defaults when I was setting up my compute instance, and I could select to have much stronger compute power. So here in compute, I have this compute cluster, and it's just a standard. I forget the exact size, but basically if you want this to be faster, you just gotta beef up your compute power, or unfortunately you're kind of just waiting around, but sorry about that. In the meantime, I can just talk and people can ask more questions, but I am going to go back to this experiment. I actually don't want that. I want to go back to the designer, and I want to look at my multiple regression. So that was the last thing I was doing. And then we're going to add on to splitting the data set, like I mentioned. But before I do that, I just want to show the latest visualization results. So like I mentioned, my coefficient of determination has gone up immensely. It's looking like a pretty great model now. And again, I don't remember these, but I do remember earlier on, especially with the first experiment that I ran, some of these errors were much higher. So it's good to know that my errors are going down and my coefficient of determination is going up. All right, so what I want to do next is to go ahead and split that data. So what I'm going to look for is the split data module over here on the left-hand side. And I'm going to plop that in there. And I can get rid of these receptors for now because I'm going to need to reformat this. And so I want to connect this module to the top of split data. And like I mentioned, I'm going to be using 70% of the rows and 42 as the random seed. And if you are running this and you enter the same random seed, then you're going to get the exact same results that I'm getting because there's the same randomly picked rows that are being selected. And then what I want to do is to connect this to the score model. Oh, sorry. I need to bring this into my training and then bring the rest of this into the score. And then I can press this nice little button to auto layout. Did that change anything? Okay, there we go. And then let me run this for now and not waste any more time so that I can do a little bit more explanation while this is running. All right, so that is just taking a moment. And so now we're going to see slightly different results that we've taken our columns in our data set and split out 70% of the data to send over here to our train model that's going to be trained using the linear regression model. And then we're going to see what happens in just a moment to our results. Yes, 42 is the answer to life, the universe, and everything. But you definitely can use other random seeds, and I encourage you to use other random seeds and see how that affects your values for R-squared as well. I think that there's a lot that you can do to slightly change the result that you're getting for your R-squared score. I'm not going to have enough time to go through all of that today. I do encourage you to try it out on your own, but just even changing the amount of rows that you're splitting has a slightly different output on the results that you get. And it's hard to predict that. You just kind of have to see it. I think even now I can't predict whether that, R-squared score will go up and down. It really depends on which rows that you're picking and what the data looks like there. All right, so that is running. And I'm going to go back to VS Code in the meantime. All right, so we just split our data, and as an exercise, and what's nice in here, I'm kind of calling them out, but there are exercises in this Python notebook that encourage you just to kind of try this out multiple times to compare R-squared values for the runs. Again, this notebook doesn't have, it basically just has instructions, and the other notebook has a lot of executable code cells that you run, and that might be the better place to kind of try out some of this a little bit more quickly. Definitely the execution time in the Python notebooks is pretty fast. I wouldn't say instant, but you'll get your results very much quicker, and there's a little bit more visualization in there. So definitely good to refer back to better visualize this data and experiment and go through some of these exercises. So the next topic that I want to go over is cross-validation. And so with cross-validation, what this is going to allow you to do is to split your data multiple times between your test and your training data. And so generally what happens is we're going to use 10 folds, and I think that's just the default number of folds that you use to evaluate a model. And so these folds are created by basically just taking different groups of data. So we have 10 folds across something like 140 rows, if I recall correctly, if that's 70%. So they're going to be evenly grouped groups of folds with different data in there. And all of those different folds are going to have different scores associated with them. And the resulting R-squared score that we're going to get is the average across all the folds. So this is another way that we might be able to better split our data and kind of evaluate how well our score will hold up to different sets of data. So this is just a way to continue to kind of condense your data and look at different sets of data and compare the output score. And I will get into that in just a moment. So I'm going to go back to my browser. And this is done. So let me go ahead and evaluate this model. All right, so now I can see that my coefficient of determination went up even more. So before it was about 81%, and now it's at 84%. So what this is telling us is that we get a different R-squared score. It's a better R-squared score, and that seems like a generally good thing, I think. But we can go ahead and compare that in a moment to our folds and how we can get that average of all of our folds and see how the coefficient of determination applies there. Generally, splitting your data helps you prevent overfitting the model, and overfitting is basically just training your model to predict exactly based on the training data set that you give it. And if you overfit, your model is going to be less likely to hold up to new data that you introduce when you're training your data set. So that's kind of the importance of going through, not only splitting your data, but trying some of these different methods like the cross-fitting that we're about to do, just to see how well your data performs under different portions or fractions of your data that you're feeding it. But so far, I think that we're generating a pretty good model, I would say. So now let me go ahead and introduce the crossfolds. And so what I'm going to do here is to look for the crossfold module. Cross-validate. Sorry, there are no results. I don't remember exactly where that is. So let me just try to search again. Is that under model scoring and evaluate? Okay, yep, there it's there. Maybe I spelled something wrong and I didn't know it. So I'm gonna have cross-validate. And for this, I want to validate my target variable. And unfortunately, I don't have that auto-populated for me again, but it's all right. And so what I'm going to do is to feed in 70% of my data to this cross-validation model. And then I'm also going to be looking for this other linear regression module. So I'm going to be running the same set of data through different models and comparing the results of those. There we go. And so then I'm going to bring this output for the cross-validate. Oh, I need to give it a minute. Back into the evaluate. So let me go ahead. I'm going to run this now so it has time to kick off. I'm going to use the same experiment to run. All right, so here what I'm doing, I'm splitting my data. I'm training it over here using no cross-validation, just the 70% of the rows. I'm also taking 70% of those rows and running it through the cross-validate model. And we will take a moment to see what happens after this. Are there any questions I can help answer now? Hopefully this won't take as long because I see that a lot of these modules have already been run. I'm just introducing these two new ones that it has to go through to model and then the evaluate step. So we should be able to get our results fairly quickly. All right, almost there. And I'm going to go ahead and look at this cross-validate model and just browse at the outputs that I get here. So there are a couple different things that I get. In addition to just the score results, I get the evaluation results by fold. And here is where you can see each of the folds. So like I mentioned, I have 10 folds. There we go. 10 folds. So just scroll down a little bit. And what I'm getting at the end is different coefficients of determination, or R-squared scores, for each of those folds. And you'll see that they vary quite a bit from about, there's one really low here, 28%, up to about 96%. So again, this is just kind of a good way to break up our data and to see how our model is performing against these different folds. Some of them are very, very bad. Some of them are pretty good, maybe too good. And the final result that I'm going to get, the final R-squared, is going to be the average of all of these. So let's go and see what that is and compare it to the result not using our folds. So the previous result that I got was that 84%. And with introducing the folds, I'm at about 78%. So my results are lower for my R-squared score. But that is not necessarily a bad thing. Again, before I possibly could have been overfitting my model, which is why it has this greater R-squared score. It's just basically learning how to predict the data that I'm giving it too well versus, splitting the data up, running different data sets, different folds. I can see this R-squared score. So this is kind of just a good practice to go in and evaluate your R-squared score and what you're getting there. All right, so there are a couple more things that I'd like to do, but probably only one more thing that I can do. So let's see, we just went through the cross-validation model. I'll just talk through rich regression. So rich regression is another method that we can do to basically test or basically help train our model. And what this is going to allow us to do essentially is to, it's going to allow us essentially to kind of, I don't want to say ignore, but put less emphasis on these outliers in our data. So this is a great type of regression to do if we do have some outliers in our data. One thing you can do is just get rid of that data, but you can use ridge regression and also referred to as L2 regularization, and I'll show that in the designer, but you can use ridge regression basically to kind of fit your predicted line better over the cluster of data and put a little bit more emphasis or kind of ignore those outliers. So just a representation of this visually, you'll see that the orange line, is that small? You'll see that the orange line is my initial prediction, and it's fitting okay. It's fitting okay, more or less, but it's trying to account for these two outliers here. When I use sklearn ridge regression, I can fit this different line, this different predicted line, which is shown here in red, better to my cluster of data. So this is just a good way to really just account for data that you assume is going to be more similar and kind of put less emphasis and less effort to some of those outliers. So I will show what that looks like now. Essentially what we would do to run that is to change this L2 regularization weight. So we've been using just the default, which is very, very low of 0.001. But if you wanted to introduce and kind of see how your model responds differently using ridge regression, all you need to do is change the regularization weight. So you might change it to something much greater, like 0.1 or 0.2 even. And even changing this regularization rate and running your model over again and evaluating the results, you'll start to see how changing this can actually affect your R-squared score and what you see there. But I will not go and do that now because I don't want to take up more time just running a model. I do want to spend the last 5 minutes just talking about deploying our model and going through what that looks like. So deploying the model is really the key to being able to kind of share and productionalize your models that you're using. So this is going to be the step that you take once you're happy with the model that you've trained and experimented with, and now you're ready to deploy the predictive model so that you can then allow others to use it. So let me now show the steps to do that. Okay, so I should be back in my browser now, and I'm going to go ahead and use this same multiple regression model. All right, sorry about that. Okay, there, that option wasn't there before. Okay, so I want to create an interference pipeline. I'm going to do a real-time interference pipeline. And when I do this, several different things are going to happen. You'll just see that momentarily. So you'll notice that some of my modules disappeared and some were added. So I have these web service input and web service output modules. And those are basically going to allow us to test out our model in real time and generate an input so that we can test out our model in real time and apply that not just inside Azure Machine Learning, but we can just take it out of Azure Machine Learning and call the endpoint to test it out in our applications. So let me go ahead and press submit. And what this is going to do is to run the experiment one more time and just generate the latest results using these new inputs. And then following that, what I want to do is deploy this when that's done. And so what that's going to do is deploy to my Azure Kubernetes compute instance, and that's going to create this endpoint that I can go and test out. And that will just take a moment. Okay. Any questions? I don't, Whisk on the Rocks, I don't know exactly what grid search is. I see that Sarah, you shared a link there, so let me follow that. But yeah, I hope that helps answer your question. I'm not necessarily sure what grid search is. Okay. All right, so that is almost done. All right, and going back to VS Code, there's just a few more steps that you'll see that I need to do to be actually able to deploy and then go ahead and test out my endpoint. After I have an endpoint readily available and I go to the endpoints section in Azure Machine Learning, I'll be presented with this test tab. Under details, you can see a little bit more details about the endpoint and how to consume the endpoint. Here is this really nice view where you can actually just go and test with other input data and actually try to see how well your model will perform with some of this different input data. And let me go back to my browser. All right, so that is done. I am going to go ahead and deploy a new real-time endpoint. I have this compute target. And then when I'm deploying here, I'll get a little bit of a status up here about that it's preparing to deploy, creating this real-time endpoint from our model. And very shortly, if not already, I should be able to see the endpoint here. Not quite yet. There we go. And so here I mentioned I see the details about my endpoint. And then I see the endpoint URL, which will be available shortly, and just describes this URL that I can use to use in my applications to call this endpoint. It's just taking some more time. All right. And I'm going to switch back over to VS Code for just one moment. And that is the end of the notebook. Definitely, I would take some time to go through these examples and especially go through the exercises that I called out. We didn't have a good chance to visualize bridge regression, but however, I will be back on Thursday and I will be primarily in VS Code and going through more of these regression models. I'll probably do some of the more less covered ones. So I probably will kind of start with simple linear regression, but then we might do some ridge regression. We might move on to other types of more interesting regression just to give you a little bit more examples into how you can use different regression models to generate your R-squared scores. And I think that's about it for today. I do just want to close out with showing my contact information here, so feel free to reach out to me again if you have any feedback, if you have anything else that you'd like to see in a future live stream. I'd love to know that. And I don't have the resources shared here, but hopefully y'all have those. I will stick around for a few minutes after, and I think that's it for now. So we have another live stream tomorrow morning, and then I'll be back on Thursday morning. So have a good night, y'all, and see you then.